Right, welcome to the first section here and looking at properties of acids. And I thought I would start doing this with the modules, and that is giving you a quick syllabus check, because it's important that you understand the syllabus back to front, the terminology that's used, because a lot of times in questions when they write them, the words that you find in the syllabus sometimes sneak their way into questions, and you can use those key words to help you retrieve the information from your brain. And so you go, that's right, they're testing this. So even though the question might be on a context that you are not familiar with, they might be talking about some unusual acid that you've never seen before, but because they use the word, let's say, monoprotic, you go, that's the section of the syllabus they're talking about. Let's just think of the concepts now and problem solve the answer, as opposed to getting freaked out about the actual specific example that they're giving you. And so I think we'll make sure we start doing this with our videos and hone in with the syllabus. It also helps my students as well know that when they make their study notes, that they can provide a clear link between the syllabus and the notes that they're writing. But also, if you have a look at the study cards, remember I'm giving you a small sample of the study cards in this first section. The rest of them you'll have to buy the study cards course or deck. But when I do the study cards, and I'll flick one up here so you can see that the bottom of the study card has the syllabus dot point that's related to the concept, and then it has the video in the bottom right, and that sort of helps you. So if you're studying with your study cards with a friend and you can't recall the information, or you're a little bit confused, you know exactly where to go with the syllabus, and of course you know what videos to watch. It just makes your study more efficient, so you're not searching and trying to find something, you can go straight to it. So let's check out the syllabus. Now this is the first section of the syllabus here. The first inquiry question, properties of acids and bases. And what we're going to be touching on here, we're going to be looking at the properties of bases and acids and what makes them, so the key features and ideas. In 2 videos time, we're going to be looking at how do we name them in terms of the IUPAC naming system. And we're going to touch on these a little bit. So the reactions between acids and bases, because that's actually the reactions that they do are part of their characteristics, their properties. So we're going to touch on those and do some little practice experiences with that, but then we're going to come back later and look at them in a little bit more detail. So we're going to continually to revise frequently. So if you've watched the study skills video on how frequent to revise, you'll understand about spaced repetition and constantly revising your materials. So this video here, we're going to focus on this section here. We're going to be looking at what are acids and bases, and then these ones we're going to get to within this section. So let's get started. Alright, so this is a bit of a revision about what are acids and bases, which is sort of done from like year 9 in junior school, and we touched on it in the year 11 course as well. But let's just revise it, bring it fresh to your memory, and then of course you've got to constantly revise it. So one of the big things here, you can see that acids taste sour, and you can see this boy here, he's got a sour expression on his face, and that is because of the fact he's tasting some lemon, and lemon has got citric acid in it, and that acid means that it tastes sour. So in class, what I do, of course, after the kids have explored and washed their hands appropriately, etc., you have some sour lollies, right? Because the acid on the outside of the sour lolly is, what is it? I think it's malic acid, and sometimes it's also, what is it? I'm having a memory blank. Malic acid, and I think it's citric acid. Okay, so it's malic acid and citric acid. We can see a picture here of a test kit, and so we know that pH, that acids have a pH range between 0 and slightly less than 7. It's not a definitive number classification system. Remember, pH is just a system in order to describe the concentration of hydrogen ions, and we're going to get into more detail of that later. But we can have minus pHs. We can have acids that have a minus pH, and we have superacids. So we can have different ways of measuring them, and when we have superacids and they go down into the minus area, we don't talk about pH anymore. We can use another scale to describe that. But most common, we come into this idea of percentage hydrogen or proportion of hydrogen, and we're dealing with hydrogen ion concentrations. Now, up until now, we have been learning that, especially in the junior school, that acids are compounds that release hydrogen into solution. So if I was to give you the good old example of hydrochloric acid here, let's just make that a little bit bigger, that hydrochloric acid will dissociate to give you a hydrogen ion and a chlorine ion, right? Or a chloride ion, we should say. And sulfuric acid, so H2SO4, that will dissociate, and we can have two H pluses and a sulfate. Now we're going to explore these more in terms of what constitutes an acid, but that's what we've been talking about so far in the junior school, okay? And we're going to discuss a little bit later on about why we use a single arrow here and why there's a single arrow here, and sometimes you can write sulfuric acid with a double arrow. If it's a very, very dilute solution of sulfuric acid, then it has more of an equilibrium property to it. But in most of the cases, we sort of think about it in terms of a strong acid completely dissociating, right? We make that assumption. So I put a little asterisk there because of the fact we're going to find out that our definition of acids is not satisfactory. And so we're going to look at a little bit of the history on what that is. But up until now, and especially in this video, we're saying for the moment that acids will release hydrogen ions. And the more hydrogen ions you have, then the lower the pH, and so forth. What's another feature? Well, we know that they react with metals to produce hydrogen gas, so we're going to be looking at that in a little prac station. They react with carbonates to produce carbon dioxide, and they react with bases in the process of neutralization. So let's go on to those. So here's a picture from a lab that we've done recently in my class, and we do every time we do this course. And I'm going to show some video here that as you watch the video and listen to the features, you'll see these features coming up with the video. So what happens here, I've got a variety of acids to test, and we've got different testing methods. We've got a pH probe there. We've got a wireless pH probe that sends some data. That's going to give us a really precise numerical value for pH. We've got some universal indicator. So there's our universal indicator chart. And we'll talk more about indicators in later videos, but you've come across that in junior school. There is our universal indicator box right there. Now, what's not showing in this picture, there should also be some litmus paper as well, some blue and red litmus. And so we're going to put samples on here, and as you can see with the samples there, that they change color, and the different color they have tells us our pH. Okay, and so very strong acids like hydrochloric acid have pHs close down to 0, and you can see that in the video and pictures that are going up there, that the color of the paper, universal indicator, turns dark red, indicating it has a low pH. However, when I do a very weak acid, such as I think we did acetic acid, right? So acetic acid is like this, CH3 COOH, and with acetic acid it is a weak acid because it only partially dissociates. You can see that we've got an equilibrium arrow here, which is saying that the direction goes in both ways. Okay, it's dynamic equilibrium. Okay, reviewing the concepts we did before. So it's a dynamic equilibrium system, but the equilibrium position, and I'm just going to make these numbers up roughly, but around about 98% is in that form there, and only 2% is in that form. And so since most of the position lies well towards the left, then there's not much H pluses there, and so therefore the pH is not as strong as HCl. And so this is a partial dissociation. We'll get more to in later videos, but you can see that the pH paper is around about 3 in the video there. It's a very light color. Then we have lemon juice as well. So lemon juice, we tested that, and that's more of an orange color as well, indicating it's a stronger pH. So here is the characteristic or the property that acids have pH within this scale 0 to 7, and depending upon the strength of the acid and the type of acid, whether it completely dissociates or only partially dissociates, we will have different pH ranges, right? HCl in your stomach is around about pH 2. So that is just some property of acids and pH. All right, another property we have is acids and their ability to react with metals. Now we did this back in year 11 if you remember, okay, but here we have a metal. So a metal reacts with acid and that produces a salt plus gas, and the gas is actually hydrogen gas. And so you can see a video of that here where we're using some acid and that we're putting a strip of magnesium in and it's bubbling away, and as it's bubbling away it's producing hydrogen gas. Now we can capture that hydrogen gas, which you can see a picture here or a video, and we can use that gas and we test it with a match to identify it's a hydrogen. And what we're doing there is we're going hydrogen gas, we're combining it with oxygen, and that's going to give water plus energy. It's an exothermic reaction, and we have the pop test. And so this is a classic test for the presence of hydrogen gas, because remember, hydrogen gas, oxygen gas, CO2 gas are all colorless gases. So how do you identify them? Well, you put a match near it. If it pops and explodes, then it's hydrogen. If it doesn't explode, then it could be oxygen or CO2. Then you have to do other gas tests, which we'll talk about later. So that is that one there, producing the salt magnesium chloride and hydrogen gas. Now let's have a look at acids and carbonates. So here is a station that we do with acids and carbonates. I guess we're using sodium hydrogen carbonate, right, which is, or the common name is bicarbonate. And so the acid here is vinegar, the good old vinegar reaction. So we've got vinegar is just acetic acid. So we've got acetic acid here. Then we've got some sodium hydrogen carbonate, which is a bicarb. And so what's going to happen there is the sodium will join up to the acid there, and it's going to make some sodium ethanoate or sodium acetate. So the Na, CH3, COO minus, right? And that those charges cancel, make a neutral salt. And then we have also some water, and then we have some CO2 gas. And so that CO2 gas bubbles away, and we can identify that with the classic lime water reaction here, which we've done in year 11 and done in junior school as well. Now, bringing in some revision from last module, remember lime water is calcium hydroxide, and if we've got some calcium hydroxide going on there, you should know that that is aqueous. And then what happens is when the CO2 comes into that, I might just get rid of that arrow. So when the CO2 comes in, then you're going to form some calcium carbonate. So calcium carbonate, remember all carbonates are insoluble, and so that's where we get this white precipitate forming. And here's the KSP data for calcium hydroxide, which is on the chemistry data sheet. It's 5.02 times 10 to the minus 6. A classic reaction, but that is a feature of acids. What is another feature of acids? Well, another feature is the fact that they can react with bases and to do neutralization reactions. Now, when that happens, and we're going to come back to this concept again, all right, we have a proton, we have reacting with a hydroxide ion, and that produces water. Now, that reaction produces energy. It's an exothermic reaction, okay? And so we're going to learn that with a lot of the examples that we get in this course, we're going to learn that an acid plus a base gives salt plus water. And if you were to do a net ionic equation, this is what you would get, okay? You would see that it's just the protonation, that is the addition of a proton to a hydroxide, which means that's going to give you water and plus energy. Okay, and we're going to learn a little bit more about how to write that equation with a little bit more sophistication later on. But essentially, that is what's happening there, okay? And that's a neutralization reaction. So here is a little video of a neutralization reaction that we did in the lab, and this is using vinegar and bicarb again. And what we did is we got some Pasco pH meters, and we put that into the beaker and we mix the two together. Now you can see in the video that we're starting off with the temperature around about 25 or so. When you add the bicarb, what happens to the temperature? It's starting to go down. Really interesting. Doesn't that just contradict what I just said? Well, you'd think so, but think about what's happening here. All right, this is where I want to get your problem-solving brain into action here. So I just said that aqueous H+, oh look at that, plus is down the bottom, we should put it at the top. Aqueous H+ combines with aqueous OH- to give us water. That's exothermic. Okay, why is this other one endothermic? What do you guys know that we learnt in the last module about the dissolution of solids? So you should remember from before, and also from module 4 in year 11, that when you dissolve a solid, the first thing is you've got to break bonds. You have to break the bonds to pull the ions away from the crystal. So remember, breaking bonds is what? Endo or exothermic? Remember, it is endothermic. You have to put in energy to break something. So we've got the breaking bonds of the crystal, endothermic. And then you have to separate the water molecules so there's room for the ions to go in. That's also endothermic. So two endothermic processes. And then forming new bonds is exothermic, right? Well, when we look at what's happening here, right, we're forming new bonds here, and so therefore it's exothermic. But in this instance, when we've got sodium carbonate, we're starting with a solid, so energy has to be put into the system to break apart and pull apart all those bicarbonate ions, right? And so therefore, overall, because we're starting with a solid and adding it to a liquid, the overall enthalpy process of dissolving the salt plus the neutralization happens to be endothermic. Okay, so there's lots of more going on here than just this simple process of that, but keep in your heads, highlight it, write it out, that neutralization reactions, when they're in solution already, this protonation reaction is exothermic. And we're going to look at more reactions in more videos to come, especially in titrations, where we can see this concept occurring. Anyway, I hope all that makes sense. You've written a lot of stuff down in notes, detailed, highlights, etc. Do what I do, constantly activate your memory recall and test yourself, draw it out, and I'll see you in the next video. All right, before we go to the next video, I want you to check out more courses that we have here on our YouTube channel, which are just small snippets from the actual bigger courses that we have on theflipteacher.com. Of course, with all of our courses, we try to incorporate practical sessions. We have study cards, we have posters that you can print off and stick around your room and do a lot more. We have up to 68 or more videos per course. That's like 9 to 10 hours of material that really delve deep into the syllabus and looking at essential content, skills, mathematical manipulations, and a lot more. So if you like that, go over to theflipteacher.com and check it all out, and I'll see you in the videos.